In this video, we're going to go over how to build a linked list, and this will also show us how to write constructors of linked list class. So as a reminder, we're using this node struct, and we're just doing a singly linked list structure. So each struct is just holding like a single value, it's just a string, and a pointer to the next node. So again, I'm going to show you two different, actually I'm going to show you only the recursive version of the build function, and then I'm going to show you a non-recursive constructor. So here is an example of how to fill a linked list recursively. And in this code, I am building it inside of main, and then I'm printing it inside of main as well. So it doesn't have any, class around it. It's just building the structure and then sending out a pointer to the front of what it built. For this particular one, because, well, for a couple of different reasons, I'm having it built via user input, and so the user enters in elements, and whatever the user enters is going to create and fill each of the node structs. Now, the way that we're going to do this is we are going to do this recursively. So at the top of the file is going to prompt the console for the console input. The base case here is that when the user puts in the pound sign, it's going to indicate that it's done and stop the recursion. And then what it does on every recursive call is it creates a new node. It fills in the value of that node with whatever the user put in, and then it links the it links the node that it's created. It links the node that it created. It links its next to whatever comes out of the recursive call to build. So it will, in a backtracking way, it will create a node, and then on the way back up, it will link it. And so this is just like a really slick way to build a linked list through recursion. Again, I'm showing you this because these structures are inherently recursive, and it's interesting to think about, and you should think recursively. We're going to start thinking recursively when we start doing trees. However, when you do build the linked list structures for your projects, you're not going to want to write them recursively because we're not building them this way. We're building them with huge files of really, really long sets of inputs, and the stack that's created on every call is going to cause problems. But this is a really nice implementation of a linked list build, and so I wanted to show it to you. And it's really interesting to think about these kind of recursive calls. So let's kind of walk through the recursion really quick. So it creates a new node, and let's say that on the console I put in A first. So it's going to go ahead and fill the value of A, and it's going to call build, and so it's going to say that results next is going to link to whatever comes out of build. And then whatever comes out of build is going to come from the next recursive call. It's going to create user input again. Let's say I put in B. It will fill in that value. It will create this next, which will link to whatever is created next. So on that recursive call, it's going to allocate another node. It's going to fill it in. Let's say we did C. And then on this one, let's say that we put the pound sign. So on the fourth recursive call, a null pointer is going to be returned. And so that So that is going to link a null pointer to that next, and it's going to keep backing out of it, and then eventually it's going to return result, and when it gets back into the first recursive call to build, that is going to be what's actually returned here, because that result is the the pointer to the very first node that was created. So kind of a cool little implementation. I will run it in Memer in just a second, but I want to show you the class version of this. So I'm going to show you how to write this build code inside of a class, inside of a constructor, and I'm also going to write it iteratively, which is how you should be writing your linked list functions. So again, this is the linked list class. These are our private member variables. I went ahead and wrote up a default constructor. In this case, the default constructor is just going to initialize these private member variables. So we just have two. So it's going to set the front node to a null pointer, and it's going to set the size to 0. So let's look at something that isn't straightforward. Let's look at the parameterized constructor. So the parameterized constructor is going to take in an n value, and it's going to prompt the user for that many values to build the linked list. So sometimes with linked lists, it's kind of easier to separate out the first and the last and then do everything in between. So here I have the code to set up the first element outside of the loop. So what I do here, and by the way, this assumes that there's at least one node to add, so this wouldn't work with an n equals 0 call. So we're going to want to initialize our size to 0 so we can increment it every time we call new. So here we're going to get something from the user. We're going to allocate our first node, and our first node is going to be called add. We're going to increment the size because every time we call new, we know that we've added something to our linked list. So I think a good way to keep track of the size of a linked list is to just increment it every time you call new. We're going to go ahead and use the user input to fill in the value of the node. So let's say the user put in A, B. Let's say it was called for n equals 4, and let's say the user put in A, B, C, D. So we're going to put in A as the first user input, and then we're going to set adds next to null. That's what it says to do there. So that way, this is going to work for a single list, a list that has a single element in it. Now we're going to set the front to add. So front is the only way that our linked list knows our linked list class knows where the start of the linked list is, so this is really important. You can't forget that. So that's just going to create a another thing that points to that first one that we just created. And then I'm also going to set a pointer called prev. I'm going to initialize it to null pointer for now at the top. But I just want to have a node that I can keep track of the last element. So prev is always going to keep track of the old element because that's what we're going to need in order to link up our structure. So the first thing that we do in the loop now, and this loop's going to run n-1 times so that it's going to create all the rest of the nodes. So the first thing I'm going to do is I'm going to save add. So now prev is going to point to wherever add pointed to. And that allows us to keep track of the old node. We're going to get something else from the console and allocate new memory and increment size. We're going to fill in the value with the next user input, which was B, and then we need to link them together. So because we saved prev, because now add has been replaced, it's now the new element, we still have access to the last element. And what we're going to do is set prev's next. Instead of setting it to null, what it used to be sent to, it's going to be set to that element that we just added. And then we're also going to set the element we just added's next to a null pointer. Doing that here allows us to, whenever we're done, to make sure that we're ending our linked list with a null pointer. we could also do it outside of the loop just one time if we wanted to, whenever we're done. Alright, so then the loop runs again. So the next time the loop runs, it's going to allocate memory, fill it with C, and it's going to, move the prev to here. It's going to have add point to this new element, and then right here it's going to update prev's pointer to point to the one that we just added, and then the last one is it's going to point C's null pointer, or it's going to set C's next to a null pointer. So we are going to just do 3, because that's probably plenty. So that's the idea of how the parameterized constructor works and what the code looks like. So the big thing about when you build linked lists is that you always have to keep track of the previous element in order to link the previous element to the one that you're creating. You also need to make sure you allocate new memory every time you add a new node. And you have to remember to always set what the front is and that the last one links to null pointer. Another good tip is, like I said, anytime you use new, make sure to increment your size. So inside of our Memer, I have this code programmed up. So let me start with the build function. So this is the build function here, the same code that I showed you. And so inside of main, we can run this I don't think I'm inside of main. Sorry. So it's prompting me for some inputs. So I will do A, B, C like we did, and then pound. And then it prints it out because I called print. And so that is testing both the build and the print function. Now to thoroughly test this, you're going to write lots of tests using Google Tests framework, and you'll also want to actually check that the linking is correct, and so check that the size is correct, a lot of other things, but this is the basic idea of how it works. Now if we want to implement, or if we want to check the class version, this is what the class looks like. So here's that parameterized constructor that I showed you, same code that's on the slide. So how does this work? So for this one, we are going to call the parameterized constructor on 5, and then we'll just print it. So let's try that. So here we'll have to do 5 because that's what I passed in, and then that's what we'll print. Okay, so that is it for building a linked list.